Okay, today we're going to talk about functions, but before we can discuss what a function actually is, we need to talk about other parts of the vocabulary that becomes very important in our unit on functions. Okay, the first thing we want to talk about is a relation. And what is a relation? A relation is a set of ordered pairs. Okay, a relation is a set of ordered pairs. So if I, for example, have a table, and our table has both x and y coordinates, and let's just say our coordinates are 4, 8, and 12 for x, and then for y, 9, 10, and 11. So we would make a notation of our ordered pairs by putting them in a set of brackets. Keep those ordered pairs together, so that would be 4 and 9. 4 is x, y is 9. The next one would be 8 and 10. 8 and 10. And our last set of ordered pairs here would be 12 and 11. Okay, so we can set our ordered pairs up on a table, and we can actually write them out in the form using brackets. Okay, so let's talk a little bit more about what each part of this means. So the first thing we're going to look at is domain. And what is the domain? The domain are all of the x coordinates. All of our x coordinates. And what would that look like looking at our ordered pairs above? 4, 8, and 12. Those would be our x coordinates. Those are the domain. The range are going to be all of the y coordinates. And what are all of our y coordinates from our table up above? 9, 10, and 11. So a function is just a set of ordered pairs. The domain are all the x, and the range is all the y. So now what is a function? A function is a relation, so that would be a set of ordered pairs that has exactly one value in the range for each value in the domain. So basically what that is for every x value, there is only one y value. Okay, so that's how we would identify a function, or that is what a function is. Now there are certain things, there are 4 ways that we are going to be looking at in order to identify what a function is. So I'm going to start another sheet of paper because I want to make sure that I can fit them all on here. So we are going to identify functions. Okay, so the first way that we are going to identify functions is from a graph. So I'm just going to sketch a graph. Okay. Now, in order for us to decide or to determine whether this is a function or not, we are going to use something called the vertical line test. Vertical line test. If I'm taking my pencil and I'm coming across my graph from left to right, and I am only touching 1 point at a time on my vertical line, then it is going to be a function. So if a vertical line passes through more than 1 point at a time, then it is not a function. Okay, so if I take my vertical line and I'm coming and I'm looking at that diagonal line, and as I come across my graph, I'm not touching more than 1 point at a time. So therefore, yes, this is a function. Okay, what about if it looked like this? If I come through, am I going to pass or touch more than 1 point at a time? I sure am. If I do this vertically and I'm coming straight through, aren't I going to land on 2 points at the same time? There would be 2 points here at the same time. So this is not a function. Now we only use that vertical line test for graphing. All right, how about the next one? It's a table. So I'm going to quickly just do an X and Y t-table here. Okay, I'm looking at my X coordinates. Is any of those X coordinates repeating? I have 2 of those. So this would not be a function. The X coordinates are repeated. It's okay if Y is repeated, but not X. All right, what about from an equation? The third type is equation. So if I have y equals 3x plus 7, and I just say that x equals 2. So if I do y equals 3x plus 7, y equals 3 times 2 plus 7, y equals 6 plus 7, y equals 13. If I keep putting that number 2 each time into the equation, I am still going to get 13 as my answer. It will never change. So yes, this is a function. Yes, this is a function. What about if I have the equation x equals y squared? Okay, and I will say that x is equal to 4. So if I put 4 equals y squared, then we know that we have to take the square root of both sides. And the square root of y squared is y, but the square root of 4 can be 2 or negative 2. So that would be no. One value for x gives us 2y possibilities. Remember, one value for x, one value for y. Okay, the last example is called mapping. And you will have two oval circles. One would be your domain, and the other is your range. So we could have 2, 3, and 5, 9, 12, and 15. So we could say, pointing the arrows point from x to y. So what I would do with the mapping is I would make a list of your ordered pairs. So my ordered pair would be 2, 12, because the 2 is pointing to the 12. And 3, 9. The 3 is pointing to the 9. And then 5, 15. I'm looking at my x-coordinates. None of those x-coordinates are repeating, so yes, this is a function. All right, I'm just going to abbreviate now. This is my domain. This is my range. Again, I'd make a list. So I would have 4, 3, 4, 2, 4, 1. All of these are repeating that x value of 4. So no, this is not a function. All right, one last example. Here's my domain, my range. Okay, my domain, 3, 6, 9. My range, -6. I have 3, -6, 6, -6, and 9, -6. Okay? Once again, underline your x values. I have 3 different values for x. Doesn't matter what y is, okay? It is important that the x not be repeated. Since I am not repeating x, then this would be yes. This is a function.